Hello everyone and welcome back to another video, and today I want to finally take a look at the Z390 AORUS Master, which is yet another Coffee Lake motherboard that I have acquired. And basically why I have this is, first, I kind of wanted one because, well, I'm a Gigabyte motherboard fanboy. And also this is basically the backup board for the 8700K. Now the 8700K isn't in this. This is actually a Pentium G4400. This is only to protect the socket because I don't have a socket protector with this. The CPU does fit in the socket, but if I tried to turn this on, it would probably catch fire because that's a Skylake CPU and a Coffee Lake motherboard. They are not compatible. Anyway, so yeah. Why is this my backup motherboard? Well, basically, my main motherboard for the 8700K is the Maximus 9 Apex from Asus. And don't get me wrong, that is an amazing board, but it has its fair share of issues. The main issue is, it is a Kaby Lake motherboard. It's a Z270 board that has been modded to also run with Coffee Lake. And while that, works mostly fine, there are a few drawbacks. Like, for example, that the board was not really designed to take a 6-core or even 8-core CPU. And in some places you can see that. And there's also some other drawbacks of running a Z270 board with a Z370, Z390 CPU. Mainly, SLI doesn't work. So if you want to run an 8700K on a 9 Apex with, you need a custom BIOS. And that custom BIOS will either not support hyperthreading or will not support SLI. I am not aware of any BIOS that supports both. And the problem is, if you want to run SLI, having a CPU score that's low becomes a much bigger issue because, well, your GPU score it's not gonna double, but it's gonna rise pretty high. And an 8700K with hyperthreading does only about 24,000 points in Firestrike for the CPU part. And if you have a graphics score that's about there or higher, your low CPU score will start significantly hurting your overall score, which is the one that the HW board ranking is based off. So not having hyperthreading, which is about a 30-ish% performance boost, is kind of a problem because, well, now your 24,000 turns into whatever 30% less of 24,000 is. And you do that while having SLI, which means you have much higher GPU scores than usual. So yeah, not ideal. So I wanted a board that can do SLI with hyperthreading. And that basically meant just get a Z370 or Z390 board, because those don't require any modded BIOSes to just work with the 8700K, because that's the boards that it was meant for. And yeah, of those boards, this is basically my choice. There are a few boards that are theoretically better. For example, if I somehow got my hands onto Gigabyte's internal Z370 or Z390 SoC LN2 boards, I would of course take one of those, but those officially do not exist, and you can only acquire one if you have very good contacts somewhere in Taiwan or China, where those boards have been exclusively made as engineering samples, and you also kind of have to just be lucky and get one of the boards that are not already owned by someone else or haven't been scrapped yet, because basically Gigabyte gets rid of those engineering sample boards, and the only way how you can get one is if the guy at the scrap heap recognizes it as a rare board and is willing to sell it to you. Which, as far as I know, is how that Z170 SoC LN2 ended up with me. It's apparently was also destined to be scrapped, and then someone saved it. But yeah. So there's Gigabyte's internal boards, which would theoretically be better. There's the Maximus 10 Apex, and then also the 11 Gene, but I couldn't find any of those, and the one time where I could find a Gene, it was horrendously expensive, and I was just like, no. And yeah, I mean, there's a few other boards that are decent. But basically I wanted an AORUS master because it's a board that just works, and it's a Gigabyte board. I've worked with Gigabyte before, so I kind of know how it works. This board even has a new BIOS that has the new Gigabyte BIOS style that you see on like X570 and stuff. So this BIOS now looks exactly like the BIOS on my B550 Master, so, you know. And yeah, it also has a much better VRM than the Apex. It is a T topology. It's not a 1 DIMM per channel, that's like the main drawback for the RAM overclocking, yet I have seen this do 4600. How stable, I don't know, and it was at like pretty extreme settings, but I have seen this done 4600. My Apex just about does 4600 too. So this is actually not that much worse than RAM overclocking, but when it comes to like what I was able to achieve, yeah, it's about like 4000-ish. That's with 2 DIMMs. For a T topology, you can sometimes get stability boost if you use all 4 slots, because, you know, it's a T topology. But I don't have 4 really good B-die sticks, I only have 2 really good B-die sticks, so yeah. But anyway, yeah, that's sort of the main reason why I wanted this board. It's just like, you know, I find it cool, and I wanted something that can do SLI with hyperthreading. And also I wanted a board that like will just work, because Z390 is meant for the 8700K, whereas Z270 only works with mods, and there's some issues. Then there's also the part that the Apex is an Asus board, and Asus boards sometimes decide that your day isn't shitty enough, and they would just refuse to do something that you needed to do very desperately. Not to say that Gigabyte boards don't do this, but they do it a lot less frequently in my experience. Yeah. That's enough exposition for now, so let's get into this board specifically. So, yeah, let's just start with the VRM, shall we? So this VRM is a 6x2 plus 2 phase. So we have an 8-phase controller. That controller is an old friend on the channel. It is an IR35201. We have seen this controller on pretty much all the LGA1151 high-end boards. It is on the Apex, it is on the EOC Formula, it is on the Z170X SLC-LN2. This is a from the time high-end 8-phase controller from International Rectifier, and it's running in 6+2 phase mode here. So we have a +2 for just the iGPU, which is the 2 phases with the direct discrete MOSFETs here. And then we have 6 phases, which are doubled to 12 for the vCore VRM, using IR3553 40 amp power stages. Yeah, so per phase, this is as strong as the Apex, but instead of having 8 phases, this has 12, and it's also using power stages instead of dual NFETs. So this VRM is just straight up better than what the Apex has. So per phase, same strength, like these are the IR3553s rated for 40 amps, and the dual NFETs that the Apex uses are also rated for 40 amps. So, you know, 40 amps per phase. But here you get 12, the Apex has 8, and these are more efficient because they're power stages instead of just dual NFETs. So, you know, better VRM, which kind of to be expected. This is Z390, this was meant for the 9900K, which is an 8-core, whereas Z270 was meant for the same CPU but with only 4 cores. So, you know, kind of to be expected that this VRM is significantly better. As for the doublers, we have them on the back here. I'm actually not too sure what these are, but they're probably IR3599s, because that's probably what they are. I'm not really aware of any other doubler that... Well, there's the IR3598, but I think that's only used on like older designs. These should be 3599s. I'm not entirely sure. They are very small and hard to read off, but I'm fairly certain that these are IR3599s. And yeah, so we get 3 of them on the back here, and then I guess the other 3 are on the front somewhere. There's 2. Where's the 6th? Is there one on the back that I'm not seeing? Like, that's not it. That's something else. That's for the 2 extra phases. Oh, it's right there. Yeah, so there's the fourth one. So 4 doublers on the back, 2 on the front. So yeah, it's running, like, you know, it's an 8-phase controller. It has to be doubled. Yeah, so the IR3599 is not specifically the best doubler. It's a rather dumb doubler, whereas it literally just takes, like, you know, every other PWM pulse and then assigns it to one or the other phase. Like, it literally just splits the PWM signal in half, which is how a doubler works. But there is no current balancing whatsoever. So it literally just 50% of the PWM pulses to each phase, which is, you know, how a doubler works. But some more advanced doublers can also balance current a bit more. So if it sees that there's less current going through one phase, it will shift more of the PWM duty cycle to that one phase that's pushing less current to equalize the amount of current that's going to through the two phases, which will increase efficiency and can potentially also lead to better voltage regulation, because if you have like zones in your power plane that are like higher voltage and lower voltage, that can potentially lead to some voltage regulation problems, I think. I don't exactly know that, but I'm pretty sure it would lead to some problems if parts of your power plane just start having other voltage levels that, yeah, you know. So yeah, so V-Core VRM on this, very nice. Like, this is the same strength as the Z170 OST formula. That was also a 6x2. Like, it's basically the exact same VRM, except that this is IR3553s, and the OST formula was also using the same 40 amp dual NFETs that the Apex is using. So this is slightly more efficient, but in terms of current handling capability, about the same, since the maximum rating on all of these components is 40 amps. So yeah, so like this will run a 9900K just fine. Probably not without the heatsink. Like the thing is, 40 amps is not what you're gonna run through these continuously. Like, it says maximum continuous drain current is 40 amps, but that assumes like ideal temperatures for the power stage. And if you run the max continuous drain current through a power stage, even if you have a nice big heatsink like this on it, it's not gonna be at the ideal temperature. So you're not gonna actually be running 40 amps through this. So yeah, you know, probably want a heatsink on this. Like, it's probably fine. Well, I'm not gonna say anything like that. Like, it's a nice strong VRM, but I would probably put a heatsink on this. This is not quite there yet at the levels of like the B550 Unify X, where you just have a 14 phase with like 90 amp power stages, where that you can just run without a heatsink and it will be fine. Especially because Ryzen draws a lot less current than like a 9900K will. So yeah, but like the VRM is still fine. Like, for the time, very nice VRM. Like, yeah, the VRM is nice. Like, it's better than the Apex by a mile, and it's more efficient than what the OST formula has. So this is like, of all the LGA1151 motherboards I have, this is the best VRM. At least the strongest. It might not have the best voltage regulation because doublers add a little bit of delay to your PWM signal, so the voltage regulation might not be the best. The Apex might be better in terms of voltage regulation because that doesn't have doublers. Same goes for the Z170X SoCLM2. That's also just a straight 8-phase without doublers. But yeah, like, overall this is the best VRM. Yeah. Then we have two 8-pins, which for anything that's not a 9900K can just be ignored. Like my 8700K maxed out in LinPack draws like, I don't know, like 180, maybe 200 watts according to my PMD, which one of these is gonna do just fine because Gigabyte uses the solid pin variant of the 8-pins. So yeah, like there's two variants of the power plugs. One uses folded metal pins and one uses solid pins. Gigabyte uses the solid pins, which can carry more current. So you can, like, you're gonna easily be able to do like 350 watts through a single 8-pin on this. Which, is gonna be enough for an 8700K, probably also for a 9900K, unless you do LN2. Then you might wanna have the second. So yeah. So unless you're doing 9900K LN2, you can just ignore the second 8-pin. It's nice to have it there for 9900K LN2 because the board can do it. It is, you know, Gigabyte's high-end board. Like at least from the boards you could actually buy, it's like the highest end board. So yeah. Then rear I/O. We do have a nice number of USB ports. Like, it's not the most USB ports I've ever seen, but it's a nice number of USB ports. You also get a power button and a CMOS clear. You do get Wi-Fi if you care about that. I like having Wi-Fi on my boards because I've just had bad experiences with LAN. Like, for some reason, it might be a problem with my router, but I've been having it for years on many different motherboards that when I use internet via LAN, it just drops out sometimes, whereas Wi-Fi doesn't. So I usually just prefer using Wi-Fi because my internet connection is so slow that I'm not gonna notice the difference. You also get a USB Type-C. The LAN might actually also be 2.5 gigabit, I'm not too sure, but it might be 2.5 gigabit, and then you get, you know, like standard audio section. Then, going down here, you get these two switches. So, the thing about Gigabyte boards is that most of them, at least the higher end ones, use dual BIOS. You can see it right here, there's two BIOS chips, right? Oh, actually that's not the BIOS chips, that's where the Gaming 5 had the BIOS chips. No, the BIOS chips are actually here. So the main BIOS chip is actually socketed, and the backup BIOS chip is soldered. And yeah, so you have two BIOS chips. And usually, they have automatic switching between them. So what this is supposed to do is, if your board fails to post a certain amount of times, your motherboard will switch over to the backup BIOS chip, which will then hopefully prevent it from, you know, being stuck at posting because of some weird settings that the BIOS is trying to load. Now the problem with that is, if you do some very heavy memory overclocking, you are going to have failed post attempts, which would trigger this function massively, switch you over to the other BIOS chip, and suddenly all of your settings and profiles are gone. Which is why the very high-end Gigabyte boards have these two switches, because one of them turns the automatic switching off, and the other one, if the automatic switching is turned off, decides which BIOS chip you use. So basically you can manually toggle which BIOS chip you want, which is kind of a must-have. Like, my B550 AORUS Master doesn't have this, and I have definitely run into the problem where, oh, you failed to post 3 times in a row? Well, off you go to the backup BIOS, and the only way to go back is to just unplug the power supply, press the power button for like 10 seconds, let the 5V standby rail drain, and then boot it back up, which resets the board to use the main BIOS chip. Which is about like a 1 to 2 minute process, and doing that every single time you fail to post because of some memory settings that don't work right away, yeah, that's a lot of time wasted if you don't have these two switches. Then we have a postcode down here, which a lot of people don't like having the postcode down here, a lot of people prefer having it about here. I, for my part, actually like having it down here because of how my test bench is usually oriented, but I do get the reason why some people don't like it here, because, for example, what happens if you put a graphics card in the slot down here? Well, you can't see it anymore. And then also most people have their test benches oriented so that they look at it from this side, whereas my test bench is oriented so that I look at it from this side. So, you know, for most other people, the postcode in this location would be a lot more visible. So yeah, then you also get, I think that's a reset switch, because CMOS clear is already on the back I/O. So this is, yeah, a reset switch. You also get a clear CMOS jumper again down here. So yeah, and that's about it. And then over here you get an OC button, which is, I'm not entirely sure what it does. I guess it loads some preloaded OC profile. It's pretty useless, to be honest. I've never used it, and I think I also never will. But, you know, it's there. It's a thing. That's about what I can say. And yeah, like that should basically be it for like the physical overview of the board. Like, yeah, in general performance terms, I tried overclocking my 8700K to 5.3 GHz, which is what I usually run it at on the Apex, and this board did that just fine. So in terms of like actual overclocking on the CPU, the voltage regulation on this is just as good as the Apex. And then in terms of RAM overclocking, well, of course this is worse than the Apex because it's not a 2 dimmer, it's a 4 dimmer, and on top of that a T topology. To which I may say I am genuinely impressed that Gigabyte still does this well. Like I've gotten 4400 to post, which it wasn't stable, but I got it to post pretty easily. And actually stable is like thereabouts 4000, 4100, circa that area is where I was able to actually get something like actually to pass TM5. Anything above that would just kind of error at some point regardless of whatever timings you use. You can potentially get this more stable by messing with resist, like termination settings and some certain minor voltages. Stuff that I haven't really gone that much into because on the Apex it kind of just works and I never really had to look into it, but on this board you probably do have to look into it. So RAM overclocking, of course it's not as good as the Apex. Like it has 4 DIMM slots and it's a T topology. But it's still pretty impressive that it's a T topology and I'm only using 2 sticks on it, which is basically like the exact way how you're supposed to not use a T topology, because that's sometimes actually worse than having 4 sticks on it. And I still got to 4100, 4000 stable, which for that time was still pretty fast. So yeah, like it's surprisingly good for what it is, I think, actually. But of course the Apex will just win in terms of RAM overclocking, because that's what it's made for. And yeah, so that's with the hardware stuff. Then, as I might also say, aesthetics. I really like the aesthetics of this board. This is probably one of my favorite board in terms of aesthetics, if not the favorite board. Like, I really like this heatsink design. I was actually thinking about swapping this heatsink onto my B550 Master, because it looks like the holes all line up, and the cover the B550 had is basically this, but without the silver plates and like a weaker LED. And I just really like how this looks. So yeah, like I can kind of try to put it together a bit. You know, have it like this, and then there's the audio cover right here, and then you have like, oh, my SSD still stuck to this. You have like the M.2 covers. It's kind of gonna, oh, that's the wrong way around. You know, just to give you a general idea of what it looks like when it actually has the stuff on it, and then there's the M.2 heatsink, and yeah. I like the aesthetic, I like the design aesthetic of this board. It does have RGB pretty much everywhere, like this lights up, this lights up, this lights up. And I think there's also under the board some LEDs. But even without the RGB, I think this looks pretty nice. And with the RGB, I actually really like how this part looks, because the LEDs in the cover right here, they are actually very bright, which is not how the B550 Master is. The LEDs on that are like barely visible, actually. So much so that at some point I reset my BIOS and it put them back on orange instead of blue, which is what I usually run, and I didn't notice for several days. That's how not bright they are. These ones are very bright and look really, really nice. So I was thinking about like swapping the VRM heatsink and the cover on my B550 Master, because they seem to be compatible. It's basically the exact same assembly, it's just, you know, a bit more cheaply manufactured because it's a B550 board. But yeah, like, I really like this from a design perspective. Like, it's probably my favorite board in terms of aesthetics. I just really like this sort of design. And yeah, and oh, what? I lost the thermal pad. Yeah, the thermal pads on this are like kind of like old Play-Doh, where it's like really brittle and like breaks apart very easily, but doesn't want to stick back together again. Like I ripped the thermal pad apart while pulling it off here. I'm just gonna flip it around and then use the side that's not destroyed when I put it back together. Keep that in mind with like older boards like this, since, you know, like it's kind of starting to get a bit old. But yeah, so I think the video's long enough by now. Like, yeah. I still like the board. Like, it's probably not gonna see that much use because I don't really run that much SLI. But when I do, I will use this because my B550 Unify X, well, it doesn't do SLI at all. And the Apex, well, it only does SLI when I significantly nerf my CPU speed. And actually, those older BIOSes that support SLI, they also don't clock the memory nearly as good as the new BIOS that doesn't support SLI. Actually, so much so that the Apex becomes worse than this board at memory overclocking. So, yeah, like whenever I do SLI, I will use this board. I will probably also use this board whenever I feel like not dealing with the Apex and its shenanigans. And yeah, other than that, it's just a really nice board. It's just kind of a board that I always wanted to have in my collection, and you know, now I do. I kind of wish I had a better place to put it than just in a shelf, because I can't really look at it there. But yeah, so that's gonna be it for this video. Bit of a longer one, certainly longer than my first take of it that I ended up scrapping. But yeah, I also talked about a lot more stuff in this one. Yeah, so, you know, really nice board. I always wanted to have it. And, you know, I went over everything else in detail already in the video. So that's gonna be it. Thank you both for watching, and until next time, goodbye.